Alright guys, I'm kicking out this video because a couple of students were asking me. I had given feedback to a number of people at the project presentation last week, and I gave a certain explanation to recap the full stack course, and some people were asking me to write that down, to provide it in a sort of in a written format so you could go and review it. So this is for you. So here's basically what I said. So we know that full stack is called full stack because it's adjusting, or it's kind of it's speaking to the whole flow of how we make a web application that can address the pipeline, right? The Express.js pipeline of how we process a web application. So we call it full stack because it displays the model view controller paradigm. And this is quite important to understand because in Android we're going to be getting more into that, and in Kotlin we'll make some examples as well. So what I said was that we have the front end, and we have the middleware, and we have the back end database. And the database in our case is a JSON database because we've seen the power of JSON to be free-flowing, right? To be, in a sense, unstructured. You can modify your shape of your data container under program code control. So the way you talk to your database in our case is MongoDB, and we'll be using that in Android as well. And we're using MongoDB Atlas because we want a cloud hosted environment, so potentially many different clients could talk to it. You could share data between app occurrences. And our way of talking to MongoDB is Mongoose, right? So Mongoose is an npmjs.com package which provides APIs to talk to it through our Express.js program. So our middleware now sitting between our front end client, which our user talks to, right? So there's your user, and they have connection to the internet, and the internet reaches out by the URL, right? So by the host name and port. So in our case, localhost port 3000. So our web browser is talking to Express.js web server. And in Kotlin, we're going to see how we can make other web servers as well, but we saw how to set up a web server with Express.js. And we call this the client because from the user's point of view, that's the client they're making requests to, and they're getting response back to that. And all of that is because HTTP is stateless. So every time user sends a request, they get back a response, and after the server has sent its response, it has no memory. Stateless means no memory. So the server is not going to later, if the user makes a subsequent request, the server doesn't know who you are, so you need to send all that information again. So stateless means no memory. And if you get this basic factor now, that HTTP is stateless, then a lot of things make sense in terms of why we have to do them the way we do. So our web server now is a program. We've been calling it server.js. And that is based on Express, and that receives your URLs, could be get or post URL. And we've seen how to use Postman to test those. And so now the request comes into the web server as a get or post URL. And the server implements the business logic, right? So it implements whatever algorithms you have, such as if it's a calculator, it just takes two numbers and returns them back. Now, if it's something more complicated, such as an e-commerce website, then we can also let our Express program talk to our Mongoose database. So Express may make a CRUD API, right? So it can create data, or it can read data, or it can modify or delete data records in the MongoDB database. Now, once you're here, right, once you're in the server side, then all of that is done by API calls within your server program. The URLs, the get or the post URLs conveying their or containing their query parameters. The form fields are how users enter information and then they click the submit button. The submit button has an action parameter which connects to the server.js, and server.js has API endpoints. And each endpoint can stimulate one of the basic database activities: create, read, update, delete. It could do other things, but let's just keep it simple and focus on this for right now. And these are activated by Mongoose API calls to read or get information back or write information to the MongoDB database. So anyway, that is pretty much what I said. If you need more information, we could even set up a separate office hours call to go over this more, because I can't emphasize how important this is. All basic web applications, legacy, this is the old school way of doing it, by the way, is model view controller. So again, I'm just thinking of the question that student asked, and she asked me to kind of just give a quick recap of the comments I was making. But it all happens between web browser, which the main thing we're thinking about is form, and form has fields, name, price, a number of items of a product you're ordering or something, and it also has an action attribute. And the action attribute is talking to the server program. So now URLs convey between the form. So when you click on the submit button, you engage the form action, and the browser object model, the nice thing would make this so powerful as a rapid application development environment. Rapid application development environment is Express and Node.js libraries are doing 99% of the work for you. You just really have to set up your fields and give them a name and specify what the form action attribute is. So these are URLs. And we're going to see now later on, we're going to see more in Kotlin that these are called restful. Representational state transfer. What does that mean? Well, come back when we get started in Kotlin, we'll talk about that. But restful URLs convey the form field data between the browser and the server.js program. And we saw how those URLs could be get, if we just want to read information, or post if we want to send information. Post works with JSON, so we construct a JSON body and it shoots the information over in the TCP pipe. Watch the video I made before for more details on that. So post, if you want to update or change information on the server. Or if you simply want to read, then you can use get. And if you want to specify what exact fields from the database you want to retrieve, then you would put URL parameters. They work up here on the get way of doing a RESTful URL call. RESTful URL. And if you want to write something, then you construct a JSON body in your form, and when you post, then the browser object model does the work of shooting that JSON document over to your server.js, and then it picks it apart, it processes it. It might write to modify, delete, or it might, well, actually wouldn't read back. Yeah, it could, depending on how you're doing the logic in your server.js. It could do any of your CRUD operations. So anyway, All I can say at this point is just study the notes I posted previously, and if you need more, if you don't totally feel satisfied with your understanding of this, it takes a while to think about it. It actually took me a couple of years of being a workaday programmer to totally grasp this, so we don't expect you to totally get every aspect of it, in a couple of weeks, but you should know enough to be able to draw a diagram like this by yourself and start thinking about it. And we also saw how to use Postman. So when you're developing or learning about your RESTful APIs, get or post, you can use Postman, you can stimulate, right? You can point them at the API endpoints in your server.js, which are RESTful endpoints. Keep coming back to that term because it's important. And I haven't explained that yet. I'm going to explain it in Kotlin, but this is the basic flow going from your client browser. And remember, once again, that's just running the BOM, and the BOM has a form. And the BOM, we can also make selectors on the HTML tags, and then we can point the content we're writing back. We can call the appropriate selector in Express.js, and we can write back to it. Now, server.js, he's the middleware guy, because he does the work, or maybe it's a girl, right? Don't want to be gender exclusive here. Server.js might make CRUD calls out to Mongoose, and Mongoose is the middleware in terms of MongoDB server. So Mongoose is going to talk to the database, and then it's going to return the information. Server.js is going to process it using JavaScript, right? Whatever JavaScript you're into, do your create, read, update, and delete here. And then server.js is in charge of getting the response object and writing back to a designated selector on your web page on your BOM. So we get the information in, we say request req dot whatever dot body dot form field, whatever's the name of the form field you made. So that makes your form data, your form field data. That is the program command, right? That's the JavaScript command in server.js that grabs a hold of that data. It makes it available. You can assign it to a variable here in your program. You write your business logic. You parse out to your database as necessary. You get the information back. You process it. And then you RES, you response, write it back to your BOM. If you have more questions, let's set up a Zoom call and I can go through. I can answer questions individually. Now, as long as we're here, and if you want, right, if you've got a little bit more mental energy, I'll give you a quick preview on how, because remember I said this is old school, right? This is still a lot. I would say it's still 80% out of the code out there is model view controller. But what we're going to be introducing in Kotlin now is service-oriented architecture. And that works a little bit different now, because model view controller, the controller is a monolith. It's like a block of cement. Literally monolith, one stone, right? It's Greek or Latin or something, it means one stone. So in the controller, you take all of your business rules, your logic, for example, getting the number of items the user wants in their shopping cart and the price per item, and then multiplying to get the total cost, and adding the shipping and the the sales tax and all that stuff. So the business logic is all handled here with if statements and loops and other basic declarative programming statements. Declarative. You're declaring, you're telling it what to do in program code. Now, why is that bad? Well, there's a thing we're going to be learning about in Kotlin called the solid programming principles. And I'm not going to go into it too much now, but basically what you really want is you want high cohesion, which means you want one class, right? One JavaScript class doing one job. And you want low coupling. And low coupling means few method calls between classes. Now the controller, being a monolith, it breaks that rule of high cohesion because it puts many different business logic items in that one monolithic code block. So we don't really like this too much. What we like these days is service-oriented architecture, not code-oriented architecture. You could call this code-oriented architecture. The new emerging standard now is we have many small classes, and how we connect them together is with RESTful API calls within the program. So instead of API calls between our many small classes, we treat them all like independent entities, and we do RESTful API calls between them. Now to make this work, and it's what I'm going to be talking about this week, we're going to introduce a couple of skills such as using XML configuration files. So instead of hard coding your business rules in logic, in code, if then, loops, and so on, hard coded business logic, no, that's a no-no. That's forbidden. That's just like, imagine if you see like a sign that says no smoking. I'm going to make up some signs for the class that say no, like hard coded business logic with a circle and a line through it to say that's forbidden. We don't want that. Why? Because it breaks the solid principle. Okay, smart guy, what are we going to do instead? We're going to implement service-oriented architectures, and we're going to put the business logic in code declarations into XML, which is like JSON, right? You've seen that JSON is a data description language. You're now going to see that instead of hard coding your business rules and if then and for loops, you're now going to put your business logic declaratively, just like JSON is a declarative way of handling data as opposed to SQL, which is the old way, which is schema based, very hard and rigid, just like controller is very hard and rigid. We're now going to do the same thing to our business logic that we've done to our data, which is to make it declarative, which means we can change our business rules programmatically at runtime under program control. And if you want to get a head start on that, you can actually go ahead and look at the material that I kicked out. Right, so we have our, let me see if I can find it quickly here. If you go to our lab book, which we're building up from our course, and you look at the last chapter, because you should know this is very new stuff. Stuff, by the time textbooks are written on stuff, it's usually 4 or 5 years old, and this is something employers are doing right now, right? They want this today. They don't really have, 5 years for us to write new textbooks. So I'm going to go ahead and kick something out from now to get you guys ahead of the curve, ahead of the game, get the big advantage in terms of getting you rather than the other guy hired at the job interview. So if you want to learn more about service-oriented architecture and how it's replacing code-oriented architecture, of how declarative business rule implementation is replacing hard-coded business rule implementation. By the way, there's a name for it. It's called BPEL. Just like JSON is a data description language, BPEL is a business process description language. Right, so if you want to get yourself ahead of the curve a little bit, you can go and read here I think starting from, what did I call that, chapter 10 or something? No, this is talking about our stuff this week. Now, the reason why this is pretty good, yeah, so I haven't figured out the chapter numbers yet, but just go like starting from page 87. So the reason why this is pretty good now is because normally in an introduction to programming, we know you're seeing programming for the first time, right? Most of you have not seen any program. Maybe a couple of you have, but for the most part, kind of new. So the reason why this is good, and when I was taught programming, and when all of, the previous generation, all of your professors were taught programming, they showed us if-then statements and for loops and classes, and they talked about composition and inheritance and interfaces, and they showed us the code, but we didn't have any clue, like, why is that important? You're showing us this stuff to do what exactly? Well, the issue is that if you don't understand the business context in which this is being done, then composition and inheritance are going to be very confusing to you. It's like, okay. And a lot of people say that, I've even seen it in a lot of textbooks, they say that the purpose of inheritance and subclassing is code reuse, which honestly, that's a very stupid and simplistic answer. The purpose of inheritance and composition is to create code implementations, hierarchies, is to create code deliveries, which deliver the business domain and give a high fidelity delivery, right? They realize, they make it real. They make your enterprise application real in a way which is a very high fidelity to the UML diagram. So you start by understanding the business domain. So you're writing an enterprise system for a business domain. And then composition and inheritance are ways of implementing in as good a way as possible, as high fidelity a way as possible. We paint a picture of what the business domain looks like in software. And understanding service-oriented architectures now is the final step. It's like the final, when you're opening a safe or a combination lock or something, it's the final number you put in to get the tumblers to snap into place. Because to teach object-oriented with procedural, right, with the old school code-oriented architecture, it's kind of, you can do it, but it's a little bit of a schizophrenic disconnect. And when students have a feeling they don't understand something, it's time to shift left and get closer to the original story, the genesis, the origin story of why we're doing it. So why we're doing this now. Now this is from another course I teach, and I'll be introducing a little bit of these concepts here. But the thing which you probably haven't been told, and you need to understand it for this to make sense, is the purpose of programming is to write in software to paint a picture of how the business or the enterprise works. And once you get that, then everything flows out of that. Anyway, I'm going to wrap up this video, and if you want more details on this, let me know. And all of this is answering students' questions that I've gotten on various related topics. So we will see you later on this week, and that's pretty much it. Hope you had a nice Thanksgiving, and take care. Bye.
А в деревню заехал, коней напоить, вздумал деревню гурьбой удивить. Эх, трай-ля-ля, вздумал деревню гурьбой удивить. А старая старуха сметлива была, дочку Маруську с собою вела. Эх, трай-ля-ля, дочку Маруську с собою вела. А старый старик свое дело смекнул, старую старуху он локтем толкнул. Эх, трай-ля-ля,